Today we will talk about like terms and unlike terms. Let's recall what we learned in Math 8. When you work with integers, positive one tile and the negative one tile form a zero pair. The little yellow square with the little red square, they cancel out, so this is a zero pair. In algebra, we have more zero pairs. If we have the big yellow square with the big red square, and this one represents x squared, this one represents negative x squared. So these two can cancel out. So these two also form a zero pair. One yellow rod with one red rod, this one represents positive x, this one represents negative x. If we put them together, these two can cancel out, so these two is another zero pair. So today we need to use those zero pairs to help us simplify to polynomials. This is the big idea in this lesson. So let's look at what are like terms and unlike terms. Terms that can be represented by algebra tiles with the same size and shape. So this is the definition presented in the textbook. I'm not so sure if you guys like this one. For me, I really like this definition for like terms. Terms with the same variable raised to the same exponent are like terms. That means if you have 3x squared with negative 2x squared, I only need to look at the variable. Both of these two terms have the same variable x, and the x also, this one is raised by 2 in the exponent, and this x is also raised by the same exponent too. I don't care about the numbers, which are also called coefficients. The numbers in front of the variables do not matter. I only look at the variables with the exponents on the variable. As long as the variables are the same, the exponents are the same, these two terms are like terms. Unlike terms, of course, terms that are not like terms, they are unlike terms. So let's look at how we can identify those like terms and unlike terms in each pair. So let's look at the first one, 5x and 3x. The first pair, you will see, okay, both of them have the same variable x, and both of them have the same exponent. If you don't see the exponent, that means the exponent is the invisible one. So these two terms have the same variable x raised to the same exponent. So we say these two terms are like terms. These two terms are not like terms. Although you have the same variable x, however, the exponent on this x is 2, the exponent on this x is 1. These two are like terms because you have the same variables raised by the same exponent. These two are unlike terms. Although they have the same exponents, however, one variable is x, the other variable is y, so they are unlike terms. These two are unlike terms because these two, this one has the variable xy, this one has the variable yz. You will see different variables in these two terms. Therefore, they are unlike terms. These two are like terms. Even if you see this one is y times x instead of x times y. However, x times y is the same as y times x. So you have the same variables, and those of these two variables are raised by the same exponent 1. For these two, although this one y is in front of x and this one x is in front of y, however, x and both of the x are raised by exponent 1. Y, both of them raised by exponent 2. So these two are like terms. And these two, very clearly, are not like terms. Simplifying polynomials by combining like terms. A polynomial is in simplified form when its algebra time model uses the fewest tiles possible. Its symbolic form contains only one term of each degree and no terms with a zero coefficient. So this is the definition for simplifying polynomials presented by the textbook. For me, I don't like this definition. I like the definition here. To simplify a polynomial, we group like terms and remove zero pairs. So let's look at the first example. Simplifying a polynomial pictorially and symbolically. What's the meaning of simplify a polynomial pictorially? This one means we can use the algebra tiles to help us visualize the simplifying. Let's look at the first one. 2x squared plus 3x squared. 2x squared. This is a positive 2x squared. That means I can drag 2 yellow big squares. Plus 3x squared. That means I can drag another 3 yellow big squares. How many big yellow squares are there? You will see there are 5. So if I simplify these two terms by combining them, the answer is 5x squared. Why can I combine them? Because these two terms are like terms. If you look at the algebra tiles, you have the same shape of the squares, including the size. If they are like terms, we also can simplify this polynomial symbolically. If they are like terms, when we simplify these two terms, we only need to add the coefficients of the like terms. The coefficient of the first term is 2. The coefficient of the second term is 3. 2 plus 3 is 5. Then I only need to copy the variable with its exponent 2. So the answer is 5x squared. In grade 9, we still can use algebra tiles to simplify a polynomial. And then we need to make the transition to simplify symbolically. Especially in grade 10, when we simplify the polynomials, we are expected to simplify symbolically. The next one, negative 5x plus 2x. If I want to use the algebra tiles, negative 5x means I need to drag 5 red rods. Plus 2x means I need to drag 2 yellow rods. And in this case, I will see the zero pairs because we just talked about the zero pairs. 1 red rod with 1 yellow rod. These two got canceled out. They are gone. And this is another zero pair. 1 yellow, 1 red. They form a zero pair. They are gone. So right now you will see you only have 3 red rods left. So that means if you simplify these two like terms, the answer is negative 3x. Since they are like terms, I also can simplify this polynomial symbolically by adding the coefficients. The coefficient of the first term is negative 5. The coefficient of the second term is positive 2. Negative 5 plus 2 is negative 3. The answer, I put on -3, then copy the variable x with its exponent 1. But the 1 can be invisible, so we can ignore the exponent 1. This one, -x squared plus 3x. -x squared means I need to drag one big red square. Plus 3x, that means I need to drag 3 yellow rods. From the algebra tiles, I will see those tiles, the red one with the yellow one, they are not in the same shape. So I will know these two terms are unlike terms. If they are unlike terms, you are not able to combine them. So if you are not able to combine the unlike terms, let's just leave the polynomial there. Since they are not like terms, we don't need to talk about simplifying symbolically anymore. Let's look at the last example, in example 1. 4n squared minus 1 minus 3n minus 3 plus 5n minus 2n squared. Let's look at how we can use the algebra tiles to simplify that one. The first term is 4n squared, which means I need to drag 4 big yellow squares. Minus 1, that means it's a red little square. Minus 3n, drag 3 red rods. Minus 3, drag another 3 red little squares. Plus 5n. This one means I need to drag 5 yellow rods. Minus 2n squared, 2 red big squares. How many zero pairs can you see? For each zero pair, one big yellow with one red, big red, they are zero pairs. Cancel them out. One yellow, one red. Cancel them out. Then look at the rods. One yellow, one red. Cancel them out. One yellow, one red. Cancel these two out. One yellow, one red. Remove this zero pair. So right now, let's look at how many algebra tiles are there left. So you will see you have 2 big yellow squares. These 2 yellow big squares represent 2n squared. Then I still have 2 yellow rods left, plus 2n. 4 little red squares, that means -4. So that's how I can use the algebra tiles to simplify such a complex polynomial with 1, 2, 3, 4, 5, 6 terms into a 3-term polynomial. This 3-term polynomial is also called a trinomial. So let's look at this time how we can simplify this 6-term polynomial symbolically. I recommend you to use the highlighters to help you identify the like terms. 4n squared, its like term is -2n squared. So I will use the yellow color to highlight the like terms. The next one is -1, which is a constant term. Can you find another constant term which is its like term in the polynomial? Here it is. It's -3. Let's use the pink one for -3n. Are you able to find its like term? The friend, the like term of this pink one is positive 5n. You guys will see, looking for like terms is just like matching friends up. If two friends have the same features. So right now, I can add the coefficients of the like terms respectively. Yellow was yellow, 4 minus 2. This one is 2n squared. Pink was a pink, negative 3n plus 5n, negative 3 plus 5 is 2n. Negative 1 minus 3, green was green, it's negative 4. So that's how I can use the highlighter to help me simplify a complex polynomial symbolically. So right now, let's look at example 2, investigating situations that represent polynomials. Write in the polynomial to represent the parameter of each rectangle. The first rectangle is this big one. If we want to find its parameter, the parameter means it's outside the distance of the shape. So if I start from here, I move along each side once and go back to my starting point. So how far I need to go, that's called parameter. Let's look at, this is x, this is x, this is x, this side is x. So this side is also x, this side is also x, this side is also x, this side is also x. If I want to find the parameter, I just add all the sides up. So this side is x plus x plus x, plus this x, plus this x, plus this x, plus this x, then plus the last x. Let's look at each x, positive x, is 1 yellow rod. So how many yellow rods are there? They are all yellow rods. That means they are all like terms. So then I can combine them into one. If I combine them, 8 yellow rods become 8 yellow rods. So the parameter of this rectangle is 8x. Likewise, if I want to find the parameter of this rectangle, it's exactly the same. This is x, this is x, this is x, this is 1, this is 1, this is x long, x long, x long, this is 1, this is 1. If I want to find the parameter, I add all sides up. So that's the upper side, plus 1, plus 1. The bottom side, x plus x plus x, plus 1, plus 1. So you can use the highlighter this time to help you look at all the like terms, like terms, like terms. Okay, these ones, constant terms, are like terms. Let's look at how many x's are there. 1, 2, 3, 4, 5, 6. So that means I have 6x, 6 yellow rods, plus 1 plus 1 plus 1 plus 1, that's plus 4. So the parameter of this rectangle is 6x plus 4. So we need to work backwards right now. Each polynomial represents the parameter of a rectangle. Use algebra types to make the rectangle. Find the dimensions of the rectangle. This is a working backward question. You know the polynomial, you need to use the algebra types to find 4a plus 2. So 4a plus 2, let's draw one yellow rod. One yellow rod, this one is 1a This side is 1. This side is also A. I want a 4A, so I put the other yellow rod next to this one. So this one is also A. A, this is 1. So you will see this is 1A plus 1A plus 1A plus 1A. You will get 4 A's. 1 plus 1, that's 2. So this is one way to represent the rectangle whose polynomial equaling 4A plus 2. You also can do 4A plus 2 in this way. So I have, okay, so this one is 1A. This one is another A. So I want another rod, yellow rod, because this one is 1, this one is A. This one is 1, this one is A. So A plus A plus A plus A, 4 A's, plus 1 plus 1 plus 2. Okay, the next one, 10B. For 10B, I find that this rectangle looks like this one. 1B, 1B. Let's use the big yellow squares. And this one, 1B. This one, 1B, 1B. 1B plus 1B plus 1B plus 1B plus 1B. It's 5B. On this side, I have 5B, so I only need to put another 3 big yellow squares underneath. So 1B, 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 and 1B, another 5B's. 5B on the top, 5B in the bottom, 5B plus 5B, 10B. Simplify a polynomial in 2 variables. A polynomial may contain more than 1 variable. Here is the polynomial in x and y. Simplify the polynomial by grouping like terms and combining like terms. I will still want to use the highlighter. I use the yellow color for the first term, 4xy. Can you find its like term in the polynomial? Its friend, which is also its like term, it's plus 2xy. Negative y squared. Let's use the green color for that one. Can you find its like term? Its like term is here. Negative 3x squared. Can you find a like term for negative 3x squared? There's no like term for negative 3x squared. So the blue color is alone. Negative x. Can you find its like term for negative x? There's no terms anymore. So negative x is the pink color alone. So right now, I can combine the like terms. I have 2 yellows. Both of the yellows are like terms. I only need to add the coefficients up. 4 plus 2, 6. Copy the variables. Green was green together. Negative, this is negative 1y squared minus 3y squared. Negative 1 minus 3, negative 4y squared. Then I have blue color, which is only 1 color. That means I don't have its like term. Then I only need to copy this term. For the negative x, I only have 1 color on that one. So this one is by itself, alone. I copy it. So this polynomial can be simplified into 6xy minus 4y squared minus 3x squared minus x.